It now promises to be a cosmic Christmas for astronomers as NASA postponed the launch of the state-of-the-art James Webb Telescope to the 25th of December. This is set to be the biggest leap in space observation since the Hubble telescope was launched in 1990. Webb stands 3 stories tall and as wide as a tennis court. It has quite the journey ahead of it, being deployed to orbit around the sun some 1.5 million kilometers away from Earth. NASA says Webb is theoretically sensitive enough to detect the heat of a bumblebee at the distance of the moon. The telescope will use futuristic tech to help us see into our cosmic past, stretching over billions of years. Dr. Jacinta Delhaize is an astrophysicist with the University of Cape Town. Let's find out how big a deal this really is. Jacinta, the world of astronomy is very, very excited, and maybe if you explain this to us properly, we could jump aboard this excitement train.
Yes, absolutely. It's definitely a Christmas present for scientists all around the world. If indeed the James Webb Space Telescope, or JWST for short, actually does launch successfully and safely, we will all be holding our breath. This has been delayed by many, many years, so this is a momentous occasion. James Webb Telescope is going to be launched on the 25th at about 2:20 p.m. South African time aboard an Ariane 5 rocket from French Guiana. And the James Webb Telescope is special because it has a mirror that is about 6.5 meters across. Now, this might not sound big, but this is an enormous thing to be launching into space, not to mention all of its solar panels and everything. It's much bigger than Hubble, and it will actually be detecting slightly different wavelengths. So Hubble can detect optical light that we can see with our eyes, and also ultraviolet, which is a bit higher energy. Then James Webb will be able to detect optical and infrared, which is a bit lower energy. And we want to do this because objects in space that are further away, as the light travels through space towards us, it gets stretched and reddened. And so we want to be able to see light that's a bit redder than it originally was. And this is going to help us detect galaxies and stars so far back in the history of the universe, so far away, that we might be able to see the first stars forming after the Big Bang, which is incredibly exciting.
Explain that to me, Jacinta. How do these telescopes help us understand the history of the universe?
That's a great question. So as you look deeper into space, you're actually looking back in time, and the further away, the further back in time. And so as this light is stretched to longer and longer wavelengths and it gets redder, that's meaning things that are further away. And so this telescope is almost like a time machine. So we can see galaxies as they were in the past. We can see stars as they were in the past. We may even be able to see planets. And this is going to help us understand what happened throughout the entire universe. How did galaxies and stars evolve? Which will really help us understand our place in the universe and our history, and maybe even where we'll go in the future.
All right, take a flight of fancy, Jacinta. What would be the most exciting thing to discover through this telescope?
Well, I studied galaxy evolution, so for me it would be understanding how galaxies form stars, and how supermassive black holes in their center kind of destroy the star formation and kill the galaxies. But if I'm honest, it would be really exciting to find another planet going around another star that is Earth-like. I think that would be really exciting.
All right, well, we can't wait until the 25th of December. Jacinta, thank you so much for joining us, an astrophysicist at the University of Cape Town.